Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the practice questions on constructions. If you need any extra help on constructions, if you go to Corbettmaths and watch videos 72, 73, 74, 78, 79, and 80, there'll be useful videos tutorials for you. Alternatively, you could scan the QR code in front of the booklet. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, so let's have a look at question number 1. So question number 1 says, use a ruler and compasses to construct the perpendicular bisector of AB. And we've been asked to clearly show our construction arcs. So we've got the point A here and the point B here. So let's join them up to make the line AB. So let's get our ruler and take our pencil and join up those points A and B. So we're going to join those points up. So that's the line AB. And we've been asked to construct the perpendicular bisector of AB. So to construct a perpendicular bisector, well, hopefully you've watched your video tutorials on that, so you know how to do that. But get your compass and put the point of the compass on the left-hand side of the line and set the pencils over halfway of the line, so over half the length of the line. So as you can see here, the compass and the pencil set so it's over halfway of the line. Now what we're going to do is we're going to do an arc below the line, like so, and we're going to do an arc above the line, like so. Now you could, if you want to, do one big arc, so you could do one big arc if you wanted to, like that instead, rather than a little one there and a little one there. It's up to you. Now, keeping the pencil and compass the same size, you're going to put the point of the compass on the other side of the line, on B. And then we're going to do an arc below and above, or that one big arc, so something like that. And as you can see, those two arcs have 2 points of intersection here and here. And if we draw a nice straight line through where those arcs intersect, the line we draw will be the perpendicular bisector. It'll cut the line AB in half and at right angles, perpendicular bisector. Okay, so let's get our ruler and pencil and do that. So as you can see, we've lined up the ruler and we're going to draw a nice line through where those arcs intersect. So there and there. And that line we've drawn is the perpendicular. It's perpendicular because it's at right angles to AB, and it's the bisector. It cuts the line AB in half. And if you wanted to, you could get the ruler measure from here to here and from here to here and see they're the same length. And also you could get your protractor and check that's a 90-degree angle, and that's it. Okay, let's look at our next question, question number 2. Okay, let's look at our next question, question number 2. So question number 2 says, using a ruler and compasses, construct the bisector of angle ABC. So we want to construct the angle bisector. So we've got this acute angle, and we want to construct the angle bisector, so that's the line that cuts that angle in half. So if that angle, for instance, was 50 degrees, when we construct the angle bisector, you then get 25 degrees and 25 degrees. Okay, so let's get our compass and pencil, and we're going to put the point of the compass on the point B, there where the two lines AB and BC meet, and we're going to do an arc on this line AB, like so, and keeping the compass the same size, then you do an arc on the line BC, like so. And you can see we've now got two arcs crossing the lines AB and BC. Now we're going to get our compass and our pencil, and I'm going to put the point of the compass on where the arc and the line AB intersect, so there, and I'm going to do an arc somewhere towards the middle, because I know that whenever I construct the angle bisector, the line's going to go this way. So I'm going to draw an arc towards the middle somewhere, and then keeping the compass the same size, I'm going to put the point of the compass on the point where the arc crossed the line BC, and I'm going to do another arc again towards the center. And where those two arcs intersect, if I join that point up to the point B, then that will be the angle bisector. So let's do that. And that's the angle bisector. And if we were to get our protractor, actually let's get our protractor and let's check that. So we've got the angle ABC. The angle ABC, whenever I printed it, was 50 degrees. And as you can see, the angle here, this angle here below is 10, 20, 25. That means the angle above is 25 as well. So we've cut that angle in half. We've constructed the angle bisector. Okay, so let's have a look at our next question, question number 3. So question number 3, we've got the line CD, and we're told the line CD is drawn above, so we've got that line CD, and it says to use ruler and compasses to construct the perpendicular bisector of CD, and we must show our construction arcs. So that's a bit like question 1, where we had to construct the perpendicular bisector, but rather than having a line that was flat or diagonal slightly, we've got this vertical line, and we need to construct the perpendicular bisector of that line. So the technique's the same. You're going to get your compass and pencil, and you're going to put the point of the compass on C, so the end of the line, and set your pencil over halfway of the line. And then what we'll do is we'll do an arc in this direction, and keeping the pencil and the compass the same size, so making sure it doesn't change, we'll put the point of the compass on D, and we'll repeat in this direction, so going upwards like so. And as you can see, those two arcs intersect at two locations, here and here. And if we get our ruler and pencil and draw a nice straight line going through those two intersection points, so like so, that line will be the perpendicular bisector. It cuts CD in half, exactly in the middle, and it cuts it at a right angle. So that's a right angle there. So it cuts it at 90 degrees. And that's it. We've constructed the perpendicular bisector of CD. Okay, let's look at our next question, question number 4. So question number 4 says, using a ruler and compasses, construct the angle bisector, or construct the bisector of angle ABC. So we've got angle ABC here, and it's an obtuse angle. And we've been asked to construct the bisector of that angle, so the angle bisector. And if we think back to question number 2, we had to construct the angle bisector for an acute angle. This question is the same, but it's just an obtuse angle. So here we've got the angle ABC, and we want to construct the angle bisector. So get our compass and pencil, and we're going to set it a certain size, like so. And we'll put the point of the compass on B, and we're going to do an arc on the line BC. And we'll also do an arc on the line AB. So we've got 2 arcs, an arc on AB and an arc on BC. So what I'm now going to do is I'm going to put the point of the compass on where the arc meets AB, like so, and I'm going to do an arc towards the middle in this direction here. And keeping the compass the same size, you're going to put the point of the compass on BC and where the arc meets BC, like so, and we'll do an arc in that direction as well, towards the middle. And you'll see that those 2 arcs intersect here. And if you get your pencil and your ruler, you draw a nice straight line from B through the intersection point and carry on, that will be the angle bisector. It'll cut that angle ABC exactly in half. So let's do that. So let's get our ruler and pencil and put the pencil on B and draw a nice straight line through where those 2 arcs intersect, like so. And that's it. So that line is the angle bisector, cuts that angle exactly in half. And you can get your protractor and check it, and that angle bisector, this angle here will be exactly half of the whole angle. Okay, let's look at our next question, question number 5. So question number 5, we've got this line DE, and we've been asked to use a ruler and compasses to construct the perpendicular bisector of DE. So we want to construct the perpendicular bisector. So it's a bit similar to questions 1 and 3, but here we've got this diagonal line DE and we need to construct the perpendicular bisector. So we're going to get our compass and pencil. We're going to put the point of the compass on D, like so, and we're going to make sure that the compass is over halfway off the line. And we're going to do an arc in this direction and also an arc in that direction. I'm actually just going to do one big arc, like so. So we've got one arc there. And keeping the pencil and compass the same size, we're going to put the point of the compass on E. So the end of this line is E, and we're going to put a point of our compass there. And we'll do an arc in this direction. And as you can see, those 2 arcs intersect here and here. So if we now get our pencil and ruler and draw a nice straight line through those intersection points, that line will be the perpendicular bisector. It cuts DE exactly in half, so that's the midpoint of the line DE, and it'll cut it at 90 degrees, so it'll be the perpendicular bisector. And that's it. Okay, let's have a look at our next question, question number 6. So question number 6 says, shown below are points C and D. So we've got these 2 points C and D, and we've been asked to construct the locus of points that are equidistant from the points C and D. Now, whenever I'm teaching constructions or loci in school, what I tend to do is I tend to go outside with my class, and one of the activities that I do is I get 2 students, perhaps Colin and David, or Claire and Donna, or whatever names you want. I get 2 students and I get them to stand in the playground. I then get the rest of the class and I say to the rest of the class, I want you to stand an equal distant or equidistant from Claire and Donna, or Colin and Dave. And what will happen is the whole class will swarm towards the midpoint of the line. They'll swarm to here. But what they'll find is, because there's so many of them, they can't all fit on that midpoint. So what will then happen is the class will naturally fan out, and it'll fan out into this nice line, this perpendicular bisector, because obviously you can be over here and still be an equal distance from C and D. You can be over here and be an equal distance from C and D. You can be over here somewhere and be an equidistant from C and D. So the class will figure out to be equal distance from the point C and D. You don't have to just be in the middle. You can be anywhere on this line, the perpendicular bisector. So let's construct the perpendicular bisector, because the perpendicular bisector will be all the points that are equidistant from C and D. So let's start by joining up C and D. So let's get our ruler and pencil and join up C and D. So we've now got the line CD, and we're going to construct the perpendicular bisector. So let's get our compass and pencil and put the point of the compass on C and set the pencil so that it's over halfway the line. As you can see, it's over halfway the line. And we're going to do an arc on one side, like so, and on the other side, or you can just do one big arc like this. So we've now got one arc. Keeping the pencil and compass the same size, we're going to put the point of the compass on D, and we're going to repeat that in this direction. So we've now got our 2 arcs, and they intersect here and here. And if we get our pencil and ruler and draw a nice straight line through those 2 intersection points, we'll get the perpendicular bisector of CD. And that perpendicular bisector, all those points will be equidistant and equal distance from C and D. So we've got our pencil and ruler, and we'll draw a nice straight line through those intersection points. And that's it. So that line is the perpendicular bisector. It cuts CD exactly in half. So that point there would be where all the students tend to run to. And then they would naturally fan out in that direction. So they would construct the perpendicular bisector. And that's it. So all those points are equidistant and equal distant from C and D. For instance, if you chose this point here and measure the distance from this point to C and from this point to D, it'll be the same distance. And that's it. Okay, let's have a look at our next question, question number 7. So question number 7 says, Theodore was asked to construct the perpendicular bisector of the line AB. So we've constructed quite a few perpendicular bisectors so far in this video, and he's been asked to label his answer CD. As you can see, that line CD doesn't look right. If we've got the line AB, that line CD, it does pass through the middle, but it's not perpendicular. It has to be perpendicular, which means crosses AB at 90 degrees. And that angle there is not a right angle, or that angle's not a right angle, or that angle's not a right angle, and that angle's not a right angle. None of those angles are right angles. So it's not the perpendicular bisector. And you can see from his construction arcs, and this is why you're asked to leave them on in the exam, so whenever someone's marking it, they can see what you've done. You can see here, these two construction arcs. Remember, whenever you set your compass and your pencil, you need to set it over halfway off the line. Whenever you put the point of the compass on A, the pencil needs to be over halfway, so it needs to be over here somewhere. So whenever you do that arc, and then you repeat it on the other side, the two intersection points are above and below the line. Here, his two arcs just touch here at the midpoint. So he doesn't know which way to draw the line. He's just drawn a line and it's not perpendicular to AB. So let's explain that. He didn't set the compass and pencil over halfway. And that's it, I've just explained. He did not set his compass and pencil beyond the midpoint of AB. So whenever he made his arcs, they didn't intersect above and below the line. So that means that his line is not perpendicular to AB. Whenever he drew that line CD, it's not perpendicular to AB. Okay, let's have a look at our next question, question number 8. Okay, so let's have a look at our next question, question number 8. So question number 8 says, in the space below, use a ruler and compasses to construct an equilateral triangle with side lengths of 5 centimeters. So we want to draw an equilateral triangle. So it's a triangle where all three sides are the same length, 5 centimeters, and each of the angles are 60 degrees. So let's start off by drawing the base of the equilateral triangle. So let's get the ruler and pencil and then draw a 5 centimeter line. So this would be the base of the triangle. So starting at 0, go across the 5. So that would be a 5 centimeter line, like so. Okay, so that's our 5 centimeter line. Now what we're going to do is we're going to get our compass and pencil, and we're going to put the point of the compass on the left hand side of the line and the pencil very carefully on the very end of the line, so making sure that the compass is set to 5 centimeters. Then we're going to draw an arc above the line, and all of those points on that arc will be exactly 5 centimeters from the left hand side of the line. And then if we put the point of the compass on the other side of the line and draw another arc, making sure the pencil and compass stay that same distance apart, all of those points will now be 5 centimeters from that side of the line. And this point here where the two arcs intersect will be exactly 5 centimeters from the left hand side of the line and 5 centimeters from the right hand side of the line. So that means if we join it up, we'll have an equilateral triangle. So let's do that. And as you can see, we've drawn our equilateral triangle. Each of those sides is 5 centimeters long. So that's 5 centimeters long, 5 centimeters long here, 5 centimeters long there. We can actually mark it with little dashes to show that each of the three sides have got the same length. And also we could even mark in the angles of 60 degrees, so 60 degrees, 60 degrees, and 60 degrees. And if you wanted to, you could get your ruler and measure each of those lines and check they're 5 centimeters. And also you can measure each of the angles and check that they're 60 degrees. But in this question, we're asked to construct an equilateral triangle with side length of 5 centimeters. And that's it, we've done it. Okay, let's look at our next question, question number 9. So question number 9 says, use a ruler and compass to construct a regular hexagon that is inscribed in the circle below. So we want to construct a regular hexagon inside of this circle. So there's a video tutorial on Corbettmaths on how to do that. In this video, I'm just going to go through the steps now anyway. So what we're going to do is we're going to get our point of our compass and we're going to put it on the center of the circle. So the center of the circle, and we're going to make sure that the pencil is on the circumference of the circle. So we've now set the compass and pencil to be the radius of the circle, and we're going to keep it that size throughout this construction. Okay, now what we're going to do is we're going to mark a point on the circumference of the circle. So I'm just going to mark a little point here. This is where we're going to start there. And what we're going to do is we're going to go round and we're going to construct the vertices of the hexagon. So we're going to get a point there and we're going to do an arc here on the circumference. We're going to move and put our compass now on that arc and do another arc on the circumference of the circle. We're going to move on around. We're going to do another arc. We're going to then put the point of the compass on that arc and do another one, and then one more. We're going to put a point of our compass there, and then we're going to do another arc here. And as you can see, we've now got the 1, 2, 3, 4, 5, 6 vertices of the regular hexagon. So what we're now going to do is we're going to join up those points. We're going to join up where the arcs meet the circle. So let's do that. And that's it. So as you can see, we've constructed our regular hexagon inside of that circle. So that regular hexagon is inscribed in that circle. And we constructed it using our compass and our ruler, our compass and pencil and ruler. And in terms of that construction, if you joined each of those corners of the hexagon up to the center of the circle, you'd see that you'd have 6 equilateral triangles. And that explains why the construction works, because we set the compass to be the radius of the circle. So that means that, as you can see here, each of those equilateral triangles, each of those sides would be the same length. And so then that would be a regular hexagon. And that's it. Okay, so let's have a look at our next question, question number 10. And actually, let's just read through the question to begin with. So we've got to question 10. We're told that the diagram shows the triangle PQR. And we've been asked to use a ruler and compass only to construct the perpendicular bisector of PR. So we want to construct the perpendicular bisector of PR, and that's quite straightforward. We've looked at a few of those already in this booklet. And then part B says, repeat this construction for another side of the triangle. So we either want to do the perpendicular bisector for PQ or for QR. And then the question then carries on, says the point of intersection of these two bisectors is the center of the circle that passes through P, Q and R. And we've been asked to draw that circle. Okay, so what we're going to do in part A, we're going to do the perpendicular bisector of that line, PR. Then what we're going to do is we're going to do either the bisector for PQ or for QR, and we'll do that once we construct the first bisector. And then what we'll do is we'll see where those two bisectors meet. That'll be the center of the circle, and then we'll draw a circle, and it should hopefully go through that point, and that point. So let's do this question. Okay, so let's look at part A. Part A is to construct the perpendicular bisector of PR. So I'm going to get my compass and pencil, and I'm going to put the point of the compass on P, and I'm going to set the compass so it's over halfway of the line, so you can see it's over halfway of PR. And we're going to do an arc below and an arc above. I could do one big arc, but because I'm doing lots of different drawings on this diagram, I'm just going to do the arc below, like so, and I'm going to do the arc above, like so. And then, keeping the pencil and compass the same size, I'm going to put the point of the compass on R. And again, I'm going to do an arc below. And I'm going to do an arc above. And actually, if you see here, I'm actually going to go back and just make that first arc a bit longer, the one that I've done here at P. Okay, so as you can see, we've got our points of intersection here and here. So if we draw a line through those, that'll be the perpendicular bisector of PR. So let's do that. Okay, so we've constructed the perpendicular bisector of PR. So that's part A done. Part B asks us to do that for one of the other sides. So in terms of the other sides, we could do either PQ or QR. I'm going to do PQ, so I'm going to get my page and I'm going to turn it around. And I'm going to construct the perpendicular bisector of PQ. So I'm going to get my pencil and compass, and I'm going to put the point of the compass on Q and make sure it's over halfway. So that's over halfway there. And I'm going to do an arc below, or I suppose technically if you look at the page, it's probably slightly above. And then an arc on this side. And then I'm going to then get the compass, keep the pencil and compass the same size, put the point of the compass on P now, and do an arc over here, and an arc over here. And as you can see, there's 2 points of intersection here and here. So we're going to get our ruler and pencil and draw a nice straight line through those points of intersection. And as you can see, we've now constructed the perpendicular bisector of PQ, because the question said to repeat that construction for another side of the triangle. So we've constructed 2 perpendicular bisectors. Okay, and then if we look at our last part of the question, the last part of the question says the point of intersection of those 2 perpendicular bisectors, so that point there, that point there, that is the center of the circle that passes through P, Q and R, and we've been asked to draw that circle. So let's do that. So I'm just going to put the point of the compass on where the 2 bisectors meet, and then I'm going to put the pencil on the point R, so on the point R there. So that should be the radius of the circle, and then now I'm just going to draw that circle. And that's it. That worked out really well, actually. If you have a look there, that circle passes through the points P, Q, and R, and it's a circle, and that's the center of the circle there. And that's it. Okay, so let's have a look at our next question, question number 11. So question number 11, we've been asked to use a ruler and compass to construct the perpendicular to the line segment AB that passes through the point P. So we want to construct the perpendicular to the line that passes through a point on the line. So the first step that I'm going to do in this question is I'm going to put the point of the compass on P, so that point there, and I'm going to put the pencil on B, so the very end of that line there where B is. And I've chosen B on purpose because it's the one that's closest to P. So I'm going to do an arc there at B, and then I'm also going to keep the compass the same size, and I'm going to put it back on P, like so, and I'm going to do an arc on the other side of the line. So now, if we look at where those 2 arcs meet the line AB, P is the midpoint of that. So P is in the middle of here and here. So if we focus now just on this part of the line, if we construct the perpendicular bisector of this part of the line, it'll cross this line at 90 degrees and it'll pass through the midpoint of this section here of the line. So let's do that. Let's construct the perpendicular bisector of this part of the line. So we're going to get our compass and pencil. We're going to put it on the left-hand side of the line. Now, when I say line, I'm now only focusing on this part here. I'm going to just ignore all this part. And I'm going to put the point of the compass here on where the arc meets that bit of the line there. And I'm going to set it over halfway. I've got to make it a bit bigger because it was on P. It would have been the halfway across the line. So it's now over halfway. And I'm going to do an arc above. Actually, let's set it a bit bigger. And I'm going to do an arc above like so. And I'm going to do an arc below. And again, I'm going to keep the pencil and compass the same size, and I'm going to put it on where the arc meets the line here at B. So here I'm going to do an arc above and an arc below. Now here, if we join these 2 points up, it'll be the perpendicular bisector of this part of the line. So it'll cross this line at 90 degrees and pass through the point P. So let's do that. And that's it. As you can see, that line is perpendicular to the line AB. It crosses AB at 90 degrees. It's perpendicular and passes through the point P. And that's it. So we've constructed the perpendicular to a line that passes through a given point on the line. Okay, let's look at our next question, question number 12. Okay, let's look at our next question, question number 12. So question number 12, this time we've been given the line AB, and there's a point here C that's not on the line. And we've been asked to construct the perpendicular from the line AB to the point C, and we need to show our construction lines. So in other words, we want to construct a line that's perpendicular to AB that passes through the point C. So let's do that. Now there's two different approaches that we could use in this question. I'm actually going to show you both now, okay? So one approach that we could use is we could get our compass and pencil, put the point of the compass on C and put the pencil on B. So as you can see that there, distance, and we're going to do an arc there, and that just touches the line there at B, and then an arc on the other side over here somewhere. So that's our first step of our first approach. So now what we're going to do is we're now going to construct the perpendicular bisector of this part of the line here, because it'll cross the line at 90 degrees, but it'll also pass through the point C if we extend it upwards. So let's do that. So let's put the point of the compass on where the arc meets the line there and make sure it's over halfway. So that's over halfway of that line segment there. And then if we do an arc above the line, an arc below the line. And now keeping it the same size, we're going to put it on where it meets B here on the other side of the line. And again, we're going to do an arc above the line and we're going to do an arc below the line. Okay, so now if we have a look here, we can see that they intersect at two locations here and here, and if we join them up, that'll construct the perpendicular bisector of this part of the line. So it'll cross at 90 degrees and it'll pass through, if we carry it on, it'll pass through the point C. So let's do that. And there you go, as you can see, that line is at right angles to the line AB. It's perpendicular to the line AB and passes through the point C. So that's one approach. Now there's actually another approach to this question. This approach is probably a little bit easier. And what we're going to do is we're going to get our point of our compass and put it on C, and we're going to make sure that the arc, whenever we draw it, crosses the line AB. So it's going to cross the line AB. It doesn't actually need to be necessarily at the point B. I'm just going to do it here quite close to there. And keeping it the same size, and this is very important, we keep it the same size, we're going to do an arc now on the other side, like so. Okay, so that point and that point are the same distance from C, they're equidistant from C. Here and here and here and here are the same distance away from the point C. Now, keeping the pencil and compass the same size again, we're now going to do an arc below the line from both sides. So if we put the point of the compass on where the arc crosses the line AB here, and we do an arc below the line, like so. And then we keep it the same size and we go to the other side here and we do another arc here. Where those two arcs there intersect will be the same distance from here to here as from here to here, and also from here to here and from here to here. So this would be a rhombus if we join this up. And the diagonals of a rhombus, they're the lines that join the opposite corners, they cross each other at 90 degrees. So that means that this line will be perpendicular to the line AB. So that we draw here. So let's do that. So let's join up this point and the point C. And that's it. So that line is at right angles to the line AB and passes through the point C. And that approach is probably just a little bit easier than the first approach, and I like it. And that's it. So let's have a look at our last question, question number 13. Okay, so question number 13, we've been asked to construct the perpendicular from the point P to the line CD. So we want to construct the perpendicular from this point to the line. And again, it's actually the same as question number 12, it's just obviously this line CD is diagonal, it's not flat, and we've got this point P here. So I'm actually going to approach this question as I did in the second approach to the previous question. So I'm going to construct that rhombus and then just join up the opposite corners, and then that'll be a perpendicular line to CD and passes through the point P. So we're going to get our compass and pencil, we're going to put the point of the compass on P, and we're going to do an arc on one side, like there, and an arc on the other side, like here. and we're not letting the pencil and compass change size. We're keeping that the same size. So these 2 points are the same distance from the point P. And then if we put our point of our compass where the arc meets the line, CD there, and do an arc below the line, and then turn it over and do an arc below the line there as well. Now you can see that this point here would also be the same distance from here to here and from here to here as this point is, P from here to here and from there to there. So if we join those up, that'll be a rhombus. And then the diagonals, the lines that join the opposite corners of the rhombus, they meet at 90 degrees. So that means that the line CD will be perpendicular to the line that joins up these 2 points. So let's draw that line. And that's it. So we have constructed, it says we were asked to construct a perpendicular line to the point P from the line CD. And from here to here will be a perpendicular line from the line CD to the point P. It's at right angles to the CD and it passes through the point P. And that's it. And that's it. These have been the video solutions to the Corbettmaths Practice Questions on constructions. I really hope you found this video useful. And if you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.